Hello, everybody. It's Thursday, November 2017, and this is a short broadcast to bring you up to speed on upcoming assignments and for me to answer any questions. I'm going to start with talking about upcoming assignments, and then I'll take the questions. So just a moment, I'm going to start a PowerPoint here. I want to share my screen. Okay, I'm gonna make it a little bit smaller. Okay, my screen isn't sharing anymore. Hold on. Okay, there we go. Okay. This is a PowerPoint presentation, actually something I put together with David Bird for a recent presentation at Quantopian. But it also is very relevant to what we're doing right now. So before I jump into this, these slides, let me quickly overview what's coming up project-wise. Your very next project, as you know, on Monday is the manual strategy, and your objective there is to create something that generates trades manually. In other words, you have written the code that causes the trades. Now we're going to use exactly the same API that you've created for that for your machine learning submission, which will come a little bit later. So it's worthwhile doing the effort now to get that API working, because then you won't have to worry about it for the following project. The next project after the one that's due Monday is the Q-learning robot. We'll cover that more later, but that particular project is the Q-learning robot. Whoa, that's weird. That particular project is not directly related to trading, but it's intended to teach you reinforcement learning, which you can then apply to your final project. So the final project, you will be able to use 3 different types of machine learning, your choice which one you want to use, to create a strategy. You can use decision trees, you can use reinforcement learning, or you can use optimization. And the way to use optimization will cover, I'll cover when I announce the project. Okay, getting back to this slide presentation. The thing I want you to notice here is we see a historic time series, a stock price time series, and we're trying to, based on some historic information, essentially technical features, to predict where it's going to go into the future. But we're right here, right now, and we can't see the future, so we're trying to make a guess, perhaps with the manual strategy, or we might use regression with the regression learners to actually predict that. But the key is that we want to look back over some look-back period and make some sort of prediction. Now, algorithms that can solve this, as you know, are supervised regression learning. So we need to select some quantitative factors, and those can be our technical features, and the thing that we want to predict, and regression learning, supervised regression learning, can make that prediction for us. And so now we're going to talk about, okay, how can you apply that algorithm to this problem? Well, we take a look back over this look-back history. Let's suppose for the moment that we've already got a model built. We pump those features through our regression model, and boom, out comes our Y prediction. Well, that's assuming that we have the model, how we can use it right now. What if we don't have the model? Well, we roll back time. And let me make this a little smaller so you can see it. We need to gather some data first. So we roll back time to the beginning of this time series, and we can look back from this moment in time. We can look back and see what were the values of our features. It might be Bollinger Bands, might be momentum, whatever. And we can observe from this point forward, what was my return, the thing I'm trying to predict, why. So that's one data tuple. We measure our different factors, call them x1, x2, x3, and then we look at the y, what happens in the future. So we've got one example tuple. Now, one thing that's important when you're training your system is you have to compute your factors only at a certain point in time and not peek forward when you're trying to predict this y. So the value for your factors will be as of this particular date, and you can only use data at that date and before. Okay, so we can move forward and get another tuple of data. So we move time forward. This is the time we're at now. We get another x1, x2, x3, and a y. And we keep on doing that. We gather a new experience tuple each time. And finally, we reach the point where it's sort of the last example we can take, because if, let's say, we're trying to predict 21-day returns, the last experience tuple we can take is what happened 21 days ago, because we can't see that y going into the future. Okay, so we have this example training data. Now we can use that to train the regression model of our choice. Could be decision trees, it could be linear regression, could be SVM, any number of supervised learning approaches. And again, we're back to where we were, trying to predict that y going forward. Like I said, lots of algorithms can do this. Linear regression, decision trees, SVMs, support vector machines, artificial neural networks, and so on. Okay, now here's sort of the overall procedure you follow, and I outlined it already. You pick the factors you want to use and what you want to predict, x and y, and now you've got a model. You need to consider how accurate is this model, how confident is the model, and so on. But there's other things that we don't know. For instance, okay, we have this prediction. What do we do with it? Suppose the predicted change in the price of the stock is less than a full percentage point. Is it worth making that investment or not? So those are decisions you need to make when you move from your forecast to your execution strategy. So there's some problems with this approach, and I just outlined them. Namely, there's a lot of things you don't know for sure, and you have to transition it from just a forecast to a regression. From a regression to a strategy. Now, it turns out that I think the way to do this is reinforcement learning. I think that's really the best way to build trading strategies. And you'll know more about that after we do the Q-learning robot. But anyways, I covered the main points I wanted to cover regarding what you need to know for the project coming up Monday, and also for the final project after that. I hope this sort of outline of how to approach these projects will be helpful for you. Okay, let me take a look at the questions people are asking. Moving now to Reddit to see what people want to know about. I'll switch my screen sharing to Reddit. Oh, that's interesting. Okay, I'll just take these from the top down. What will be covered in the final exam, and what's the format of the final exam? We will cover everything since the midterm, so it's not we're not accumulating across the entire semester, just what we studied since the midterm. The format will be exactly like the midterm, 30 minutes, 30 questions, closed book, closed notes, etc. Will the stream be recorded? Yes, it will. What should we consider in manual strategy that will make the upcoming machine learning projects easier? That's a great question. Well, a key thing that actually we haven't done before, and I think is a good thing we're doing this time, is that we're getting you used to what the API is like. So we're going to use the same API for calling your strategy as you're building right now. Now, it turns out that we're not, for the project that's due Monday, we're not going to hopefully test your code. We might test it if something looks suspicious, but in general, we're not planning to do that. So what that means is you might choose to do something slightly different if it's expedient. But as we approach that final project, you better be sure to get that API going. Okay, other things. It is a very good idea to standardize your indicators. And the reason for that is for many machine learning approaches, let's just consider k-nearest neighbor and so on. It is useful to have all of your indicators sort of ranging in the same across the same general scale. Now, it turns out that decision trees are especially powerful at not necessarily requiring standardized input data. If you were, however, going to be using k-nearest neighbor, well, actually, you're not allowed to. You can only use decision trees. But if you were going to use k-nearest neighbor, you really would need to standardize your data first. You'll probably also find that standardizing, if you're going to use reinforcement learning, standardizing your data will also be very helpful because it'll help you when you're discretizing your data. It'll help you with that process significantly. So anyways, to answer that question, what should we consider? Main thing is consider how to standardize your data. Something I want to point out here that's important is when you standardize the data, let's say we're using z-score, which is a typical method. What you do is from all of your data points, you compute the mean and you find the standard deviation. And what you do is you, from each data point, to standardize it, you subtract the mean and you divide by the standard deviation. And the result is that all of your data now conveniently typically sort of runs between -1 and 1. That's essentially, -1 -1 standard deviation to +1 standard deviation. Now, there certainly are going to be tails outside those boundaries, but now it's essentially a normal distribution centered on 0. Now, you need to remember that mean and the standard deviation for your out-of-sample tests, because as you encounter new data, you don't necessarily know ahead of time what that standardized value for that new data is. So you have to keep around your old mean and standard deviation. Okay, for normalizing with other indicators, is it better to use Bollinger Band value, or can we use Dave's BBP, the percentage across the bands? So my recommendation would be to use the -1 to 1 range. It's been a while since I've seen Dave's video, but it's usually very helpful to have all of your indicators running more or less between the same min and max ranges. Okay, how would you estimate the time required for the last two projects in reference to manual strategy? I think the last project will be about twice as hard as the current manual strategy. The Q-learning robot will be about 75% as hard, maybe 50%. And I think the Q-learning robot is not hard. Okay, in order to plot and normalize data at 1.0 at the start of a date range, what if that indicator begins with a nan? Do we just divide? So I know what nan means, but I'm not really sure I understand the question. But it's okay. For instance, for the first value of Bollinger Bands, you don't have enough information to know what it ought to be. So maybe it's nan at that point. Anyways, I would expect for the first 20 days or so that you don't have data for some of your indicators, and it's fine not to display them. Are our participation marks for part 3 and part 4 yet to be posted on Gradebook? Yes, they have yet to be posted. They will be posted soon. If we are implementing DynaQ in the Q-learning project, it seems like it will slow things down quite a bit. Have students in the past had problems with being under the time limit? And if so, do you have any tips other than vectorizing code? Yes, Dyna does cause the program to take longer to run, and absolutely vectorizing solves that problem. So I think that's what you're going to need to do. Are our plotting needs available? Are all our plotting needs available from matplotlib? Yes. .pyplot, yes. For the manual strategy, can you provide some details for part 4, comparative analysis? I'm confused as to what we're supposed to do in this part. Especially, you should use the classification learned using in-sample data only. When I say classification learned, what I mean is what you have learned, the parameters you have chosen to make in-sample work well. Anyways, I'm not going to say too much there. Mainly, I want you to look at your in-sample results and your out-of-sample results and describe what they are and reflect on why they are different and what you think caused that to happen. Okay, I'm going to refresh my screen here and see if we got any new questions since I've been talking. Okay, we do have some new questions. How do we choose the factors based on indicators? The indicators are the factors, same thing. Would a moving average crossover be a factor, or the way to do it is moving average values? So the crossover is so you should create the indicators. And so for instance, let's say you created RSI. You might want to then use the transition of when RSI is greater than 50 as a I don't want to say indicator because I already used that word, as a suggestion that you should trade. So this part, this RSI greater than 50, is the logic in your program. So I want you to create some logical statements, if, then, else, and, or kind of stuff based on your indicators that tell you when to trade. Basically, is it easier for an algorithm to build parameters and place orders based on Boolean versus numeric values? In the end, you do need to have thresholds on your indicators. You need to essentially, you do need to eventually turn them into binary choices. How should we decide on holding period? Uh, well, there's no requirement on how long you need to hold or how short. You should probably create from your indicators uh, logic that tells you when to exit. So for instance, when the criteria for your logic for entering no longer holds, you might then exit. Will these slides be available to us? Well, in the sense that they're on this video, yes, but I'm not expecting to share them. For the best possible strategy, do we use the training plus test data range? For that part of the report, we're mainly just interested in the testing date range. How do these principles apply? How do these same principles apply to the Forex market? Seems like the liquidity makes it prime for some ML. Yes, Forex is well suited to machine learning. I think you can use all the same principles there. What's the average on the midterm exam? That information has been posted on Reddit. I forgot the numbers, but you can go there and see them. What would be X1, X2, X3 in training data? Those are the values on a particular day for the indicators that you create. Will the stream be recorded? Yes. Should we still load the CSV file for market strategy in our market sim file and just change it to use? So you should no longer be reading CSV files in market sim. Your market sim should just accept a trades data frame. Okay, let's see if we got any more questions. How many participation checks? We'll probably have a total of 10. Is normalize equals start at 1 and standardize? No. Okay, I understand your question. Yes, when I say normalize, I mean divide everything by the first row. So that will cause everything to be 1 at the first row. And yes, standardize is the same as z-score, if you want to look that up. Basically means calculate the mean and the standard deviation and subtract the mean and divide by the standard deviation. Is shrubbery a good indicator? An excellent indicator. For the manual strategy, would it be acceptable to engineer technical indicators that look a lot like the ones Dave articulated in his video? As in, could we use the same technical indicators but use different logic numbers to drive the strategies? Yes, but you have to use you have to generate code for another. You can only use his code for 2 indicators. You have to create a new one all on your own. Okay, I'll check one more time. I think we're about to wrap up. Hope everybody had a happy Halloween the other day. How do I combine indicators? Sequentially? How should I assign a weight or priority in developing a strategy? That's a good question. There's a couple different ways you can do this. One is you can decide that, okay, I'm going to find a threshold for each of my indicators, and if the value of the indicator is within those thresholds, then that indicator is a go. And I would require, one thing you could do is you could say, okay, 2 out of 3 of my indicators have to be thumbs up in order to enter the position. So essentially like they're voting. Another approach is to sequentially check them one by one. And essentially, in that case, you would be requiring that all of them be satisfied. Another thing you could do is assign a weight to each one and um, look at each of their values and create a sum and then kind of put a threshold on the overall sum. My advice to start with, though, is just use some thresholds. If the Bollinger um, value is indicating it's a buy, set the thresholds there and then go ahead and buy. And I would start also, just for experimental purposes, just using one indicator and kind of get that working, and then see if you can make it better by adding in another indicator. Okay, I'm going to go ahead and wrap things up. I hope that was helpful for you, and I'll look forward to seeing more questions on Reddit. Bye-bye.